right, we'll be talking about snail from module 1 down to module 6. And we have also tried to bring out simple things you need to put in place to get a successful snail farm setup. And now we're trying to get into that aspect that will encourage us more into the business, which is our module 7. And this talks about snail production, economics, and business management. Let's look at the study objective. This offers insight into the economic prospect of snail farming. We'll be expected to dive into the financial dimension of snail production, encompassing cost assessment, financial strategizing, and approaches to marketing. Additionally, we shall share light on the promising market prospect for various snail-related products, spanning from fresh snails for culinary use to processed snail goods, as well as the growing demand for snail slime in cosmetic and pharmaceuticals. Now, Unit 1, Market Analysis and Product Development. Breeding and genetics are pivotal components in snail production as they directly influence characteristics such as growth rate, disease resistance, and other desirable attributes. Here are the principal facets of breeding and genetics in snail farming. Selection of breeding stock. Initiate a breeding effort by procuring high-quality breeding stocks that either exhibit or has the potential for desired trait. Look for individuals that demonstrate superior performance in the target attribute, whether through observation, measurement, or performance record. It is essential to choose snails that are excellent health and devoid of genetic defect or diseases. Breeding system. Snail breeding can be executed using various systems, such as individual pairing, group mating, or mass mating. The choice of breeding system depends on factors like the snail species, breeding goals, and available resources. Consider parameters like genetic diversity, ease of management, and the ability to track lineage when determining the most suitable breeding system. Live breeding and outcrossing. Live breeding involves pairing closely related snails to maintain and enhance specific traits within a population. While it helps stabilize and strengthen desired attributes, it must also elevate the risk of inbreeding issues. In contrast, outcrossing entails mating snails from different lineages to introduce genetic diversities and mitigate the risk of inbreeding. Often, a balanced approach that incorporates both live breeding and outcrossing is employed to maintain genetic health and optimize desired trait. Selective breeding. Selective breeding entails the careful selection and mating of snails that possess the desired trait. It necessitates meticulous record keeping, performance evaluation, and the identification of superior individuals for breeding purposes. Traits typically selected for include growth rate, reproductive performances, shell quality, disease resistances, and tolerance to environmental conditions. Genetic improvement. Genetic enhancement in snail farming can be accomplished through methods like family-based selection, individual selection, progeny testing. Family-based selection involves the selection of breeding stocks based on the performance of their offspring. Individual selection centers on the choice of the best performing individual based on their individual traits. Progeny testing involves the evaluation of the performance of offspring from various breeding pairs to identify superior genetic lines. Genetic diversity. Safeguarding genetic diversity is crucial to prevent inbreeding-related issues and uphold the overall health and adaptability of the snail population. Periodically introduce fresh genetic material via outcrossing or the acquisition of snail from diverse sources. Genetic diversity enhances resistance to diseases and adaptability to environmental stressors. Disease resistance. Incorporating disease resistance into the breeding program is vital for sustaining snail production. Select snails that have demonstrated resistance or tolerance to common diseases within the breeding population. Employ measures to monitor the health status of the breeding stocks and implement appropriate biosecurity protocols to minimize the risk of disease introduction. Record keeping and data management. Maintain comprehensive record of the breeding program, including pedigree information, performance data, and other pertinent details about the breeding stock. This aids in tracking genetic progress, making informed breeding decisions, and identifying the most promising lines. breeding and genetics in snail production necessitate a long commitment, careful planning, and ongoing evaluation. It is advisable to seek guidance from experts in snail breeding and genetics to develop and implement an effective breeding program tailored to specific goals and resources. Breeding method: mass selection. This approach involves the selection of breeding stock based on their overall performances, regardless of their familial relationship. Still, there exhibit desirable traits such as rapid growth, high reproductive potential, and disease resistance are chosen for breeding. Mass selection is relatively straightforward and suitable for small-scale operation. Family selection. Family selection entails grouping snails from different families or lineages together, and the selection is based on the performance of their offspring. Families with superior progeny are identified and used for further breeding. This method allows for the assessment of genetic potentials within specific lineage. Progeny testing. Progeny testing involves evaluating the performance of offspring from various breeding pairs. Snails from selected breeding pairs are allowed to mate, and the offspring are raised and assessed for traits of interest such as growth rate, shell quality, or disease resistance. The performance of the progeny helps identify superior breeding lines for future generations. Reciprocal recurrent selection. Reciprocal recurrent selection is a method employed to enhance specific traits in both male and female snails simultaneously. It involves multiple rounds of mating, selection, and recombination. The best performing males and females from different females are mated, and their offspring are evaluated. This process is repeated over multiple generations to achieve genetic improvement. Selection criteria: growth rate. Rapid growth is a desirable characteristic in snail farming due to its ability to shorten production cycles and increase productivity. Show snails that have a proven track record of fast and efficient growth with the ability to convert feed into biomass effectively. Productive performance. The reproductive performance of snail is crucial for maintaining and expanding the snail population. Select snails with high fertility, a strong capacity for egg laying, and high rate of hatchability are factors to consider. Thank you.